It is. All right, hopefully we're back again and recording. Right, so this is Tom's video we're going to kick off with.
When Tim Berners-Lee proposed... When Tim Berners-Lee proposed... When Tim Berners... Oh, come on! When Tim Berners-Lee proposed the idea for the World Wide Web back in 1989, he wrote about a universal linked information system. His exact words, a place to be found for any informational reference which one felt was important and a way of finding it afterwards. 3 decades later, and you've possibly noticed that the web is a bit of a mess. What happened to that universal information system? What even is a cookie, and why do we need to accept them? There are 2 reasons that the web is terrible right now. First, advertisers, and second, people. I actually just realized that I just implied that advertisers are not people. And there's some really interesting stuff about corporate personhood and employees acting as a hive mind there. Anyway, let's talk about the advertisers. The first versions of the web were simple. Text and images and links to other text and images. You could use forms to send information, but the whole thing was stateless. This means neither the web browser nor the web server kept track of you from one page to the next. You just sent a request for a document, you got the document back, and that was it. If you submitted a form, that one response could be tailored, but after that, nope, the server has forgotten about you because it can't tell you apart from anyone else who's using the same network. Now, this wasn't long-term a great plan. In theory, you could hack together something more complicated, send forms back and forth, and people did build things like that, but they break very, very easily. It was impossible to have something both reliable and personalized. Then in 1994, a programmer called Lou Montulli, who was building a web browser at a company called Netscape, came up with cookies, adapting an old computer science technique called magic cookies. They were so useful that every other browser started to use them as well, and they got built into the web standards. A cookie is client-side storage. Your web browser sends the request to the server as usual, but the server sends back 2 things: the page you asked for and a little text file called a cookie that your browser then saves. And after it's saved, every time that browser makes a request to that same server, it sends the cookie along with it. So that cookie could contain your preferences. If you choose dark mode, then the browser would now send a dark mode preference in that cookie every single request. If the server asked for it, then that cookie would last, even if you closed the browser and restarted your computer, for years and years and years. Or a cookie could be used for authentication. So after you've logged into a site, that site gives your browser a cookie that's just a long random string of characters, but because no one except the server and that cookie have that long string of characters, it can act like a password. The browser sends it back along with every page request. And the server looks at it and goes, oh yeah, I remember you. The designers of the cookie looked at that and they knew that it could be used to track people. So there was a very, very important rule for privacy from the very start. Only the site that sets a cookie can read that cookie back. Except because of the way the web is built, sites can include material from other servers. A web page can pull in an image from somewhere else, or some scripting code, or even an entire other website included in a frame. And those other servers could all set and read their own cookies. Third-party cookies, they were called. So when web pages included advertising, well, those adverts came from the advertising company's servers, so those advertisers could set a cookie that tracked people across the entire web. If the same ad company partnered with loads of different websites, they could start building up some very, very detailed profiles. No, they might not know who you are at first, but they knew you visited that website about your hometown, and then you visited that website about your college, and then you visited that website about a very specific medical condition. Oh, and then you bought something from an online shop, so they can work behind the scenes, combining the details from that shop and their cookies, and add your name and address to the profile. All those fancy share with Facebook buttons. Well, yeah, loads of them could report back to Facebook where you were going. Hey, look, this person's looking at all these sites. So now you can tailor adverts for them, which is why you could be on a site that seems to be completely disconnected from Facebook and still see adverts that were uncannily linked to things you've been thinking about. It took a long while before regulators decided that maybe advertising companies having enormous databases on basically everything that people were thinking might be a bit of a privacy problem. The European Union acted first. The cookie law, which was the euphemistic name for this mess, meant that all the EU member countries had to put a law in place requiring consent to place cookies. That wasn't particularly well thought out because consent requires clicking OK. And if there's a confusing box in between the average person and the article they want to read, look, nearly everyone is just going to click OK. And by this point, browser makers were starting to give users options to block third-party cookies anyway. So advertisers were adjusting. They were tracking people not through cookies, but through fingerprinting, looking at all the apparently innocent individual quirks of how that exact computer was set up and how it rendered a web page, the fonts you had installed, the size of your monitor, the website you'd visited in the past, all things that individually appear innocent and safe, but which together uniquely identify each person. Browser makers and advertisers ended up in an odd war with each other about privacy, occasionally a civil war, given that one of the most popular browsers and also one of the major advertising companies were under the same corporate umbrella. So later, the General Data Protection Regulation, GDPR, put even stronger requirements in place, at least for EU citizens. Not just no cookies without consent, no tracking without consent. At all times, the user must have full knowledge of what they're signing up for and must consent to it. Even if the company's not in the EU, even if they're storing data on EU citizens outside, it still applies to them. The potential minimum fine is 4% of the company's global annual revenue, not profit, revenue, or 20 million euro, whichever is higher. And yeah, sure, maybe the EU couldn't easily fine an all-American company, but they can definitely stop them doing business in Europe if they don't pay. So all the advertisers had two options. Number one, stop tracking people. Or number two, add a big box on each page saying, hey, is it okay if we track you? And legally, you should be able to easily say no and still access the site. Opting out should be a simple one-click process. And anyone who's been on the web lately knows that's often not true. So yes, at least some of those pop-ups and frustrations are because of advertisers. Certainly they normalize the idea of intrusive pop-up boxes. But why can they put those boxes there in the first place? The web is built around freedom of design. It's one of the most fundamental principles within the box that the web browser gives you. A designer can put almost anything. For decade after decade after decade, programmers have pushed the limits of what's possible. Someone has even managed to emulate the entire Windows 95 computer in the web browser. I don't mean just making a web page look like Windows 95. I mean an entire virtual machine that thinks it's running on regular computer hardware, but is actually just simulated in code in a web browser. And that's incredible. Like, give people power to create, and some will make amazing things. But some will look at the ability to run almost any code and put almost anything on screen, at least within that box, and go, ooh, maybe I can get more newsletter signups if I interrupt the reader. Or maybe I can make people's browsers mine cryptocurrency in the background while they're on my site. So the war starts again. Most web browsers now have a separate view that you can switch into that shows just the text you want. It might be called article view or reader mode. The browser tries to figure out what the main content is, what the user actually wants to see, and puts just that text on screen, stripping out the adverts, removing all the pop-up boxes, and yes, losing all the creativity and design that the web allows. But that reader view is a lot closer to Tim Berners-Lee's original design, a place for information and a way to find it afterwards. Of course, there are already techniques to detect and defeat reader view and make sure that the user has to see the adverts or the newsletter pop-ups or whatever else. Every bit of freedom that a designer has for creativity and good is also freedom for abuse. That's true not just on the web, but in every single aspect of the online world.
Wow. Here we go. Somewhat ironic that I was just about to launch our own email list. So, any thoughts and comments about this? The web is a mess. Tom.
Yes, it seemed to me that it's taken a different direction. Actually, I've noticed that they have managed to monetize the process of turning off cookies, so that you can have them advert free, whatever it is you're watching, but you have to pay for it, of course. And under our present economic system, anything and everything will be monetized.
Yep.
Yeah, that's true.
Is this really any different than any other technology revolution, evolution? We have to go through these bumps and starts to figure out what really we want to preserve, and we don't want to over control, because that will suppress innovation.
True.
Any responses to that?
Oh.
Paul.
I think it actually goes much deeper than this, because there is the issue of advertising tracking pixels that go on a screen. So when you download or you go to a website and you look at the page, because of the way it works, it can go off to anywhere to bring an image in, for instance, and you can put a white pixel on a white screen that you never see. Yep. And that pixel, when you load that web page, will go off to some potentially nefarious website that's collecting data on you, not only putting cookies on your box, but harvesting all sorts of other information about your machine and things. And what you've then got is a total intelligent surveillance machine for anybody using the internet, whether they've allowed cookies or not. And this is the problem. I mean, on the one hand, I can see that if I want to use free Hotmail, well, Microsoft are giving me a service, therefore they want some, return from managing that for me. But on the other hand, it's really, I mean, whose data is it? Who owns me? Does Google own me? And Google, from what I'm aware, because I'm not a commercial buyer, will sell whatever data they've got to anybody who pays enough money for it. And this has got massive ramifications now. There was an article in the news today about a woman who'd had an abortion in the UK and was traveling to Texas, where it's now unlawful. And she was really worried about deleting all her browsing history for the last God knows how many years to make sure she didn't get arrested when they got there, because they can demand access to your browsing history. And I think we're heading into extremely dangerous and almost an unusable internet territory, the way it's going, if you've got any respect at all for your own privacy or your banking or what you buy online and things like that. But I'll leave it open to others to comment.
Yeah, I'd like to comment on some of those points, actually. My personal view about adverts is I'm happy with adverts, providing they're not dominating the whole page. If I see a page with 20, 30, 40 adverts on it, it's way over the top. If it has one and that's funding the site, then that's fine. It does remind me a little bit of where WhatsApp used to be. Now, WhatsApp used to be £1 a year for ad-free messaging. Now, of course, they're part of Facebook. Facebook are just about to add ads to WhatsApp. So that's also going down that long. A little bit of an echo.
Well, I don't even have a Facebook account, and that's deliberate. And if I had Twitter, I'd probably get taken out and shot, because being a northerner, I just say what comes into my mind. And it seems these days on the web, somebody somewhere will take offense at what you've said, because they're just looking to pick an argument. And I think that's another avenue that could be explored later, because nowadays, you've got the police kicking the door in of a 15-year-old who said and upset somebody on Twitter or social media, rather than sorting out the burglary down the road. It seems to have gone a bit stupid. I sort of agree with you on the adverts. It's the fact that then they are stringing everything together about you, and they're allowed to do that, and therefore profiling you where I have an issue, because they can't protect that data. And it's like when Theresa May said, hey, we're bringing this new law in. However, you will only be, the ISP, your internet service provider, will only need to track you down to the first /. So if I go to bbc.co.uk/news/Africa, it doesn't know I've looked at African news, what's stored at the ISP in huge volume for everybody and the, you know, the web providers. However, if I go to World Wide Web, help me, I've got testicularcancer.com / where do I get help? That gives everything away in the first part of it. And that's why I find her argument at the time when she was Home Secretary rather specious. And the fact these companies are putting this data together, it isn't just for marketing. It's being sold onwards, and it has massive ramifications for health records, for insurance in the future, for visiting a foreign country where they take exception to the fact that, you know, you might be of one religion and they're of a different religion. There's massive ramifications. And I don't think, I think the real problem here is we are on what is by definition the World Wide Web. And how do you regulate something that is worldwide?
Yeah, I'd like to pick up on another point you mentioned there, Paul, about abortion. So we've talked really about so far about web tracking, about, you know, you go to different sites and something will track you. But there's also an issue about metadata. And so metadata is data about data. So if you think about your traditional landline, it's going to have what time your call was and who is it from and to, and that's about it. The metadata is not going to contain what you talked about on that call, but just from, to, and the time of day. But there was an interesting article on the getting a bit of echo again. There's a bit of there was a good article on EFF, Electronic Freedom Frontier, and they said metadata is actually really quite interesting, because if you've got a metadata that someone had a phone call from their doctor, and then 10 minutes later they had a phone call to an abortion clinic, you know, you can put two and two together. What's going on?
Oh, exactly. I think metadata in many ways is easier to search and more valuable than content in many ways. If you think about WhatsApp, it's end-to-end encrypted. But unlike Signal, you know, Facebook basically track who you're talking to, how often, what time of day, and all that kind of stuff. That's their metadata, and that's their business model. You know, so in one sense, they're providing a service, and you can't argue with that. You know, and unfortunately, most of us, I'm not, to my knowledge, having conversations with anybody I shouldn't be having conversations with. But it's the fact that my, you know, sort of a reasonably large part of my social network is known to companies that I don't trust. That's where I have a problem. We saw a classic example of this in what Cambridge Analytica did with Brexit, in targeting the 2 million swing voters. I don't know whether this has been discussed before, but there's a whole documentary on it, and it's quite scary, really. But yeah, again, I'll hand over.
Yeah, fortunately, they are no more. Anyone else want to make a comment on this video? Go on then, Neil.
So, yeah, it was something that was said, Paul said earlier, about this bit about the pixel being able to actually pick up other data, transmit it, and pick up data from it. I don't know enough about computers to know why or how that's possible, but I thought, yeah, so it sounds as though each pixel is actually able to carry links that I had not realized was true at all. So yeah, how does it actually work then in this situation? Is a pixel just a singular piece of data that can carry code in some way?
Well, the pixel is a placeholder for
Just a placeholder. Okay, right.
And basically, it's the way any web page works. You know, there's a set of scripts and HTTPL and stuff like that. But that you know, when that pixel comes up on your screen, it will go and try and bring the image in. But the image is just a white dot on a white screen, or a black dot on a black screen, or a red dot on a red screen. But the fact you've gone to some external website to pull that image in, even if it's just a 1 pixel image, means that they then have a tracking cookie on you, and that's that, or other details they capture from your browser, like your fingerprint. And that is what the issue is. And there's almost no way of stopping that I know of.
Amazingly scary, isn't it? That one.
Tom. No, the other Tom.
I'm probably
Okay, to be completely accurate, a pixel actually is 6 hexadecimal digits long, representing red, green, and blue. But of course, anything can carry something else. It can carry another address. So those 6 hexadecimal characters, which of course you have millions of them across your screen, can actually carry vast amounts of information.
May I
Thanks, Tom.
comment?
Yeah, go on ahead, Tom. The other Tom.
I'm without a doubt probably the least technically knowledgeable, although I have degrees in electrical engineering and I've done computer work for a long time. But my concern and my interest is in what one does to control this. And I don't want to diverge into that topic because there seems to be interest in the details. And I've raised the question with you, Peter, and I look forward to a discussion on blockchain for the reasons I mentioned. But recently, in a conversation with a friend of mine, and I work basically in the field of gerontology from the standpoint of how can technology help older people address their needs and issues. And in a recent discussion, it was raised with me the controversy over autonomous vehicles and what should be done. And this, of course, extends to immediately to the whole question of AI and the question of, is there a utopia ahead of us, or is there an absolute destruction of humankind? And the point of the discussion I had, and there's an article in the New York Times to this effect on autonomous vehicles, that in dealing with any of these potentially apocalyptic issues through policy, one should not go on the emotions and reactions, even of the experts, but more on the basis of data. And what does the data show you? And in the case of autonomous vehicles, it was saying data on accidents, for example, take the specific example of actual human drivers stopping and blocking emergency vehicles, which is an issue that's being raised for autonomous vehicles in the United States. And people are saying, get the autonomous vehicles off the road, they're blocking vehicles. Well, we don't know what the case is for human drivers. And in parallel instances for all technologies, shouldn't it be based on the actual data rather than interactions? That's my vein of thought and interest. I don't want to diverge into that if the interest is more in the technologies.
Okay, thank you. Peter. Are you there, Peter? You have to unmute yourself. I think you're still muted.
Just press the space bar, Peter.
I've done it. I've done it. Okay, fine. Okay, I am a bit fascinated by this pixel issue. I've never heard of it before today. Now, I would say there's 2 things with a pixel. There's a physical pixel on the screen. Are we talking about the physical pixel on the screen, or are we talking pixel in an image, Peter? Can you just clarify this?
Yeah, I mean, yeah, Paul was describing it quite well just now. So when you first go to a web page, you get a whole bunch of text back, and some of those are references to images. And then your browser will then make a second request to the web server and fetch any kind of contained content, such as images or videos or whatever. So the first page would have a reference to this 0 size pixel, which is just an image, just a very small picture. And then the web browser will go and fetch that from the server. And that process, keep getting. And that process, that second process, means you're giving additional data about your browser configuration to the server, whoever owns that pixel or your picture.
And if I may, the other, I mean, you can notice this quite easily. If you're on a slow connection, quite often you'll see a web page build, and you'll see little little postage stamps with an X in the corner, which means I haven't got that image yet. And then you'll see it populated as it goes away to fetch it. The problem is with any web page, you don't know who's coded it, and you don't know who's doctored it. And therefore you don't know what it's pulling in from anywhere. It could be pulling a virus in. It could, you know, there's all sorts of things that you're relying then on your browser and your operating system to block if it's not something that should be there. On the plus side, it's a great way of building web pages, and you don't have to store all those images thousands of times. You know, you just go and fetch it each time. So, you know, there's pros and cons for it, but it can be, is the word abuse the right word? It can be used for marketing, and it can be used for other things.
Let me just go through it slowly. So it's the image coming down from the thing. Now, is that image going to be stored on my computer? Or where's it going to be done with it?
Everything on your computer is stored in a cache somewhere, and probably gets overwritten. It's the fact that it goes to a website that you don't know anything about that website to pull that image in. And it might just be a BBC News site going to Getty Images to pull in a stock press picture, and it might not be one pixel, it might be, you know, a postage stamp's worth of pixels, but essentially it's the fact that without your knowledge you're being taken to another website to display the page, and you might be taken to 100 websites on a particular page that aren't owned by the original coder of that web page.
Okay. Now, is there any mechanism I can use to guard cases, please?
I have to keep muting you, Paul, because you're causing lots of echo.
Sorry, wait a second. Is there any way I can guard against this at all, please?
Yeah, what I suggest, Peter, is that you hold those questions for the second talk.
Okay, fine. Thanks. Stop. Okay, thanks.
Barry.
Yeah, Tom a moment ago claimed to be the least technically clued up person. I would have to challenge that. I'm almost certainly that person, and I suspect, like many others, I place a lot of trust in my security software, my antivirus software and other security software to keep me safe from a lot of this stuff. And where it doesn't, I rely on my wits. So far, so good. I guess I'm asking from a position of naivety, I think, is whether there is ever any prospect of there being a technical solution to this, or are we always going to have to be sort of fearing the worst?
Yeah, good question, Barry. Can I immediately refer you to the presentation we're about to have?
Brilliant.
And by all means, raise the question again during that.
Peter, I don't mean to jump ahead, but is not blockchain technology the answer to this because you have total control and privacy over your data, or am I being naive in that assumption?
The talks today is all about traditional web technologies. I would push the blockchain discussion to another day.
Okay.
Anyone else for any comments before we have a look at the second presentation? Good. Right. Let's see if I can share my screen again. And what I'm going to do this time, I think, is just to allow any interruptions, because we haven't got many slides. But there may be some questions as we proceed, so feel free to interrupt halfway through. Right. DHCP, DNS, trackers and ads. And I've got a star there because I am going to mention one of my favorite products, but I'm going to start with the open source equivalents first. Right. So what I'd like to start off with is couple of key network services. I'm pretty sure you've come across these, but maybe not kind of absorb what they actually do. the first one is DNS, Domain Name Service. And these exist on the internet at large. And you've got to think of it as a huge distributed database. And one of its main purposes is to map domain names like bbc.co.uk to its underlying IP addresses. So it's a simple domain mapping, name to address, that exists on the internet. And it's maintained by ICANN. And there's a few popular DNS servers, there's Cloudflare and Google and many others. So DNS on the internet. And your ISP probably gives you one as well, just to speed things up a bit. I'm on Virgin Media, and that's their address of their DNS service. So second protocol I'd like to bring up is DHCP, Dynamic Host Configuration Protocol. And this is a protocol that works on your internal network, your network at home. And what it's about is when you turn your PC on or a phone connects to your Wi-Fi network, the DHCP manages the configuration of this device that's newly joined the network. So it assigns an IP to your device. It tells your device where the DNS server can be found. And it might give other information as well. And typically your DHCP server at home is probably embedded in your broadband router. If you look at the configuration of your broadband router, little tick box say enable DHCP. Okay, so just a couple of names. DNS maps names to IP addresses. DHCP manages the configuration of devices when they start up on your home network. So this represents your home network. I think I got a laser pointer, look at that. So you might have a PC which is yet to be turned on your home network, and this could be cable network or Wi-Fi, doesn't really matter. And somewhere, in the corner of your room, you've got your router or your hub, whatever you want to call it, that's given to you by your your broadband supplier. And that connects your home network to the internet at large. And on the internet, we have a DNS server. In fact, there's lots of them, but for the purpose of this, we're just only going to have one. And we've got a web server that you are trying to connect to. Okay, so that's what we got. So processes, this is kind of quite important to kind of understand this. So you turn your PC on, or your device, or whatever it might be. And the first thing that does, it sends a broadcast on your local network, says, who am I? The PC currently has no idea of its network, topology. It doesn't know where its DNS server is, knows nothing. So it sends a broadcast, who am I? And that request goes to your DHCP server located in your router. And your DHCP server will reply. It will reply, well, I'm going to give you your IP address. I want to tell you the router to get out to the internet. And I'm going to tell you where your DNS server is. So this is a one-off configuration when you turn your machine on. And now this PC has that information and can now participate on the network. So for example, if you go to your browser, you go to news.com. The first thing your browser needs to do is to map news.com to an IP address. So now it's got the DNS server address. It can go straight out to the DNS server. The DNS will reply with the IP address of news.com, and then your browser can then connect to the service. Now, does that make sense? Because this is pretty key to everything else that's following on. I can see some nods. That's good. DHCP, startup configuration of a network, DNS mapping names to addresses. Right, good. I'm glad I got some nods. Thank you for that. So let's have a look at a made-up web page. So we're sticking with news.com. We've got a web page here, and embedded in that web page may be some adverts. And those adverts will go to a different website. DoubleClick is a well-known web advert hosting service. And there may be a tracker from fb.com. I don't know who that could be. And that could be another advert, or it could be one of these very tiny or zero size images. So what looks like an innocuous website that you got from news.com actually consists of data from news.com plus all these other advert type services. Okay, so going back to our network then, let's see what we can do about this. So the first thing we can do is we can take the DHCP server out of the firewall and put it on our home network. So we go into the firewall configuration, we untick the tick box that says it hosts a DHCP server, and we create a DHCP server on our own little network internally at home. And secondly, we host a DNS server on our network at home. Okay, so, and we set up our DHCP server such when a PC starts up, it's configured with the DNS server of our server. Okay, so it's now that PC, instead of going to Google or Cloudflare or Virgin Media to do the name to IP address lookups, it's now going to a server on the local network, which we control. So we can play with it, we can control it. So now let's see how this fetching of this website works. So as before, the browser goes to DNS server to look up news.com. Now, to start with, of course, our DNS server has no idea about this, so it delegates to Google and gets that response back. So far, so good. We've got the right answer. Now, of course, this DNS server can cache that response. So if your browser does a second request to news.com, it doesn't have to go to Google to request it again. It can just reply straight back. So one good reason of having your own local DNS server is just simply speed. It should speed up your network because it'll be caching all these DNS lookups for you. However, it has a second very useful task. So let's say your web page has got this advert buried into it. And of course, your browser now is going to try and fetch that advert from this doubleclick.net. Now, our locally now managed DNS server, we can configure that to reply with a dummy IP address. And now your browser, one, it's not going to the external site called doubleclick.net. And secondly, it can't possibly display the advert in your browser. Now, does that make sense to people? Because that's kind of quite an important thing. Go on,
Peter, I didn't get that one.
Okay.
So what when you say it can't get it, I mean, how do you block? How are you actually blocking it then?
Aha. Well, so this DNS server is on our networks, on our home network, and so we can configure it. So I've configured it to say, if there's a lookup request for convert doubleclick.net to an IP address, please return 0.0.0.0. So this DNS server has been configured to give that response to that request.
But aren't there loads of hundreds or thousands of these that are, how do you ever get to know? Yeah, right, okay.
A very good question. I like your questions. Just hold that thought for 2 seconds. Yes, so we've created, so one good reason. Oh, go on, Tom.
Yes, I suspect that this is the same question that Neil has just put. My understanding of a DNS server is that it contains the dotted quad, the 4 numbers at the bottom there, of all of the servers in the internet, and that would be pretty substantial.
So what our local DNS server is going to do, it's going to do 2 things. It's going to add a DNS cache. So if it doesn't know the lookup from news.com, it's going to delegate the request to an official DNS server on the internet and remember that. So a caching local DNS server It's just a way to speed up your local requests. So over time, this DNS server learns a lot of stuff that this Google server's got. So there's no need to configure it with all the public good sites. Let's say it's going to learn that by default. But what you'll also do, you'll do a second thing, is that you'll configure this DNS server with a block list. So a list of servers that you're going to return this 0.0.0.0 with. Barry.
Sorry. I'm now confused slightly. In the middle, you've got this router and a firewall, which is the box basically.
Yeah.
Got.
Yep.
So this DNS server and DHCP server, are they circuits within the router, or they're not a physical object?
This is something that you go and install yourself. Right. So a couple of good suppliers for this, if you like, is there's an open source project called DNS Mask, and that is an implementation of a DHCP server and a DNS server. So you can download DNS Mask, you can configure it, and it will do these tasks for you on your home network. And that's exactly what I used to do. Actually, I did DNS Mask. I think it's a brilliant little program, very simply configured. Another very popular solution for this is a tool called Pi-hole. And as you probably guessed, it's based on Raspberry Pis. So I've got references at the end, but you can go and buy a Raspberry Pi. You can download an image for it and flash it, stick it on your network, and then that will provide you both this local DHCP and DNS servers for you. So these two here you have to supply to do it. Tom.
If you don't mind my jumping ahead and properly into oblivion, but does this suggest to me that if I were to hire you, Peter Lord, to come to my house and configure my DNS server and so forth, I could block out every option that I don't want except for those that I don't know about?
Yes. Yeah, send me a flight ticket, I'll be there.
You mentioned that Pi-hole can go on a Raspberry Pi. What hardware do you need for DNS Mask?
Oh, it's tiny. It's probably, a third or a quarter of a Raspberry Pi.
Does it have to be a Raspberry Pi?
No, any small, any computer on your network, DNS Mask will work on. So if you've got an Intel server that you store videos on, then you can stick it on there.
Right. I have a spare Mac laptop.
Yep. However, this isn't the only options. I'm going to move on, which to share some options which may be preferable.
Yep. Thank you.
But this is fundamentally the principle. You host a DHCP server and DNS server on your local network and use it to pass through all the good sites and block all the bad sites. Right. Onwards. So, first question you're going to ask, which you didn't, is where you get these block lists from. Well, if we go on to GitHub, there's loads of GitHub projects that has oodles of these block lists. And here's one I picked at random. And you can download these lists and it'll work with DNS Mask, it'll work with Pi-hole and other systems. And you can see here, it's got different types of lists, a list for light protection and all-round protection, a pop-up ads protection, and so on. And all of these lists work in the same way. They look for that DNS lookup. And if it's deemed to be a bad site, then the DNS server will then return the 0.0.0.0 to your web browser, and so it doesn't get displayed. For example, I actually did try this. So this is Mirror, the Daily Mirror, UK newspaper, left-wing newspaper, I would say. And you can see this first page here has got adverts on the side, in the middle, and there. And there's other stuff going on here. There's trackers going on here. And if we now install this DNS mask, or sorry, it's DHCP DNS combination, we can block these adverts, and you can see you end up with a neater web page. And hopefully you're doing some protection as well, and stopping at least a lot of these trackers that are going on. John?
Peter, it's probably just worth saying that obviously it's not dissimilar to the ad blocking software that you can install in your browser, which also will operate off lists in exactly the same way. You're doing it earlier in the process by not even letting your browser go and get those things for them to remove from. Wouldn't that fair?
Yes, it is. And everyone's jumping up to the next slide today, which is good, right? Yeah. Yes, this is true. You can install lots of ad blocking stuff on your desktop, on your PC and stuff. But note, this applies to your whole network.
Yeah.
So it'll block ads on your smart TV, for example. It'll block ads when people come to visit you. So they're not, your house isn't being tracked. So all devices on your network, because you've set up your DHCP server to give a DNS address of your own controlled DNS server, you've got full control of every device on your network. Who knows what your smart speaker is doing, or, any other devices on your network. But yes, yeah, you're exactly right with the point that you made. So now this is where I start going to product placement. So I would say you can use DNS Mask to do this, or you can use Pi-hole, and I'm sure you can find similar open source solutions. And I used to use those. However, recently I've moved to AdGuard. And AdGuard is one of these apps that can be installed on any of your devices. So I've got it running on my Mac, which I'm using here now. I've got it on my phone. I've got it, every device I've got this as well. And if you go into the AdGuard preferences, it's got DNS preferences. And in there, you can graphically configure exactly what I've just been talking about. You've got a block list in that little DNS server. And so this is another way to do it. So instead of doing a DNS server for your own network, you can install AdGuard or similar products on your single device, and that will also intercept these DNS requests for you in the same way. The advantage of tools like AdGuard is they'll do an awful lot more than just subverting DNS. But of course, if you install it on one device, it only applies to that one device. And yeah, you've got lots of settings on here. And I want to bring you attention to this, because have a look at this. 69 gigabytes of data saved. So you think about mobile phone tariffs. I mean, I don't watch videos when I'm out and about. So I've only got a 5 gigabyte plan on my phone. And this is nearly 70 gigabytes. It's avoided downloading on my phone. And most of this data saved is like ads, which are in the form of videos. They consume data. So blocking these ads can also save you a huge amount of data. It's not only about ads and tracking. Okay. However, now at home, I use a tool called Home Assistant for my home automation. And if there's interest, by the way, I can do a talk specifically on Home Assistant now. And Home Assistant as a tool, you can manage your heating and, send you alerts when your printer runs out of ink and all these sorts of stuff that you want to do at home. But AdGuard have a solution for Home Assistant called AdGuard Home, which happens to be free. And it does exactly what we've talked about. It hosts a DHCP and DNS server on your network. But instead of building your own with Linux binaries and such like, it gives you a nice friendly interface. You can choose what blocking list to install to block your ads. So that's yet another solution, another way to implement the sorts of things I was talking about.
Right, Peter, where is that running?
This, I've got Home Assistant. I've got it running in my cupboard over there, just to the left of me. And it's running on a little, it's actually an Odroid C2 single board ARM-based computer.
So it's another piece, a piece of hardware.
It's a piece of hardware, yes. Yeah. But the nice thing is Home Assistant does a lot more than just AdGuard. So it's, for me, it's very much a multi-purpose solution. And there's some reference. Hopefully that makes sense. I thought it'd be nice to introduce the idea of DHCP and DNS in your home network, how they work, and how you could potentially run them yourself on your home network to at least try to filter out some of the stuff that Tom was talking about on his video. And I must say, just anecdotally, my wife, she's got an iPhone, and when she goes to other people's houses and uses her iPhone, she's continually astonished how much ads she gets. So she goes away from the home network where she hasn't got this blocking, and it really makes a huge difference to your usability of surfing the web. Barry.
What's the business model for AdGuard? Is it just open source or what?
AdGuard is free to download on single devices. However, I did purchase a license, a lifetime license for all the devices that I own. And I think that was for about £20, something like that, which I thought was worthwhile. And this AdGuard Home is free.
The figures are 42 lifetime for 3 devices, lifetime for families, but 100 quid. Okay.
No, you can get it cheaper than that.
How do you do that?
I've got it on the links. Actually, let me just share my screen again. Yeah, put it on the references here. There's this Stack Social, and that's the place to get this cheap deal from.
Okay, thanks a lot, Peter. Thank you.
Would it be possible for you to circulate your presentation?
Yes. What I'll do is, because we've got a nice shiny website, once we finish this and I've processed the recording, I'll do a new post to our website, which will include all these references, the recording and the slides.
Just to comment, Peter, it was an excellent presentation. I actually understood
it. Good, thank you. John, you got your hand up.
Yeah, I was typing away in the chat box and suddenly got deleted, so I'll have to say it verbally. One little thing that was missing from the diagram was those internal IP addresses, namely 192.168.1.3, etc. Now, when you run a home VPN or a web server, you've got to direct the traffic. If you're not using DHCP server, separate computer, or the DNS server, separate computer, if you're just using the router, you've got to direct the traffic to the appropriate PC, Raspberry Pi in my case. So what you do is on the router, you have what's called a static IP address, i.e. address that's specific on the LAN. So typically mine might be 192.168.1.10, right, for the sake of argument. And that means that any traffic that comes through from outside through to the router for that particular application, now you'll generally find that each application uses a specific port. So for instance, TeamViewer uses 3389. Web servers, I use Nginx, but you can use Apache or whatever you like. They generally come through, I think it's on 443, I can't remember, and something else probably offhand. So you do that as a once-off, and that then makes sure that the traffic goes to the right computer, because otherwise the router wouldn't have a clue where to send the web server stuff. And similarly, VPN, I use WireGuard. Again, I can't remember the port number. And WireGuard is, if you like, a successor to a famous one called OpenVPN. And WireGuard is much simpler. It's only, I think, 3,000 or 4,000 lines of code, whereas OpenVPN is about 100,000, I've been told. And so WireGuard is simpler. And again, it's an open source freebie. Yes. And so it's very, very good for, as I say, when you're in Sainsbury's or whatever supermarket you want to be in, and you want to do some bank transactions, for sake of argument. So, and similarly, there are other ones. So I've got another computer I call a demonstrator, because I don't run any Windows software, zilch. Right? I run this on desktop. I'm just running standard Ubuntu 2022 for long-term support. And obviously, the big advantage of Ubuntu, which is a Linux-based distribution, just like Android or an Apple Mac or an Apple iPhone, they're all Linux-based distributions. So Apple argues about that. They're all Linux, so they're all pretty safe for people getting in on viruses, generally speaking. And they use a feature called IP tables, which I won't go into, very, very boring and very, very complex. And basically there you say what ports you allow in, really. So it knows on a particular computer, say my Raspberry Pi, that it'll allow 3389, but it won't allow loads of other stuff. Ports that I'm not interested in people, hackers coming in. And that's very, very common without using a DHCP or DNS server. Obviously, on the Raspberry Pi, I could put a DHCP server or DNS server. I don't know how much difference in time it makes. Perhaps somebody can tell me.
Yeah, thanks, John. I actually do something very similar. Just a minor correction. Of course, I suppose the correct way to say it is that Linux, Mac OS, are both implementations of the Unix standard.
Yes, yeah, that's more accurate. I said that the Apple deny it. Yeah.
Okay, Adrian.
Yes, can I just ask for clarification on one point? AdGuard, at one point you were telling us about having it on your system as AdGuard Home, I think, and then you seemed to say you got them on the individual devices, and then went back to the home system. Do you have both?
Yes, I do. I mean, it's a good question. I should have made that clearer. I use AdGuard Home on our network for this DHCP DNS style of ad blocking that we talked about. However, AdGuard, if you install it on your device, can do more. You know, it can actually rewrite web pages as it goes through your device. So if you install it on your device, you can get an awful lot more protection than only the DNS hack that I talked about.
So they don't conflict with each other then?
No, they work together, in fact.
Thank you.
And I will re-emphasize what I was saying earlier. I mean, I've talked about AdGuard. There's other products that will do exactly the same thing. It just happens to be the one I use now. Any other points about this? Is this the sort of thing that's of interest, the right sort of level? Is sometimes hard for me to judge.
Very interesting. Whether I understand it is another, all of it, whether I could implement it is another matter, but it will start me doing some homework.
Well, see, what I was thinking is that if you start to understand at least what DHCP and DNS are, if you see it mentioned on the configurations of your screens of your devices, you think, I know something about that.
I knew that. One of the questions that I was going to ask is that the router has a DNS or has a setting for DNS servers, but you can also put them on the computer as well. Again, which takes precedence there?
So your router probably does not have a DNS server.
No, it has, but it has the addresses for a couple of DNS servers.
So if you remember, when you turn on your home PC, it uses DHCP to discover its IP address and DNS server, and it gets that information from, well, the DHCP server. Your router does exactly the same thing on the broadband network. When you start your router up, it'll do a broadcast and say, what's my IP address, what's my DNS server, and your ISP will supply that information to it. So typically, most broadband companies will configure your home router with the DNS address of the ISP's DNS server. And then that DNS server details by default is passed on to all your local internal devices, if that makes sense. So there's not likely to be a DNS server on your home router, but it needs to know how to find the default DNS server on the internet. So it's
I did have a complication once. I have a motorhome and I have a 4G router in that. And I found that if I used the connection through my iPhone or iPad, that worked perfectly. But as soon as I tried to do that with my Mac, it wouldn't connect up until I deleted the DNS server settings in the Mac itself. So I don't know what was happening there.
Well, I use Macs, because it's a type of Unix. And when I start it up, the list of DNS servers it gets will overwrite whatever is hand configured beforehand. So I don't really quite understand how that would have worked. Maybe you've done some manual configuration there where you perhaps shouldn't have done.
Well, I'd manually configured the laptop to use one of the more common DNS servers. But I don't know what DNS server the router uses. Presumably that's provided by EE.
Exactly, yeah. When your router,
I don't know what that is.
Yeah, when your router starts up on 4G, it'll get the DNS server, whatever EE wants to offer you. It will know about that. I'm going to go to virtual hands up first. Peter Weston.
Okay, thanks. I have a problem with this. What's the matter with me? Okay, can you hear me, Peter?
Yes, you can. Yep.
Okay, good. First of all, I think it's going really well. Maybe give you positive feedback. It's going really well. Now, I've looked at Stack Social. There's a fantastic discount over AdGuard. You're exactly right. I'm looking at a family price of $29.99, which is $30. Now, is there any catch with Stack Social? Because it strikes me as a very good deal.
No, I was just as skeptical as you. And no, you just get a subscription and it works.
Peter gave this information to me about a month ago, I think, was it, Peter?
Yeah.
I've downloaded it and installed it and so on, and it was easy and fine.
Great piece of advice. Thank you very much indeed. Thank you.
Okay.
I bought Microsoft Office 2021 for Mac from Stack Social yesterday, and fine. That came back down. Okay, no problems.
That's great. Thank you.
Paul.
Yeah, I think that was a very good description. Thank you. I think one of the issues is, because I had this when I'm on Virgin Broadband and it went down during lockdown, the DNS went down. That was my diagnosis of what the problem was, and I couldn't resolve web domains. You can switch to Google or other ones, but you have to reconfigure your router to do that, because they, for their own commercial reasons, I think, and I'm pretty sure they market your data too, whether it's Virgin or EE or O2 or BT or whoever, it's data, and data is a very marketable commodity. I couldn't do it without changing configuration on the router to be able to do that. I couldn't just tap in 8.8.8.8 to get, and so I had to reconfigure basically. And the other interesting thing is, if you just want to look up an IP address, I think you have to put https:// in it. Otherwise, most browsers go to www.8.8.8.8, and it doesn't work. Just to help people out there.
Yeah, obviously with testing of AdGuard and such like, I quite frequently actually override the DNS servers that my DHCP server's given me And I just go into the Mac configuration and just type 8.8.8 and it works straight away. So I've not had to go through that. So
yeah, you can do it on the Mac quite easily. It's not so easy on the phones and on other devices. I just go into the network settings on the Mac and change it. But some people, maybe because they're running Windows, I don't know. I do know there's been issues in the past with changing, because the router has it kind of burnt in. You know, you must use the Virgin one if it's a Virgin router, or a Huawei if it's a Huawei router. And you can bypass it, but it's not easy for the Joe public to be able to do that at times.
okay, Peter, you still got your hand up? Can you put your hand down or not? Didn't want to. Okay, let's go to John then. You want to unmute yourself? You want to unmute yourself, John?
That's my standard thing. I start talking and forget I've unmuted myself because I don't want people to hear me shuffling around or whatever I do, or coughing. But I never use an ISP's routers. I find they're substandard, and often they're configured with things you can't change, such as they want you to, someone just said, using Virgin Media's DNS thingy. So I always buy one, and I found, you can buy a 30 quid router, TP-Link, which seems to work better than the ISP ones, faster for some reason. You don't get so much buffering going on. So I always use those. I keep the ISPs in and stick them in a cupboard just in case something goes wrong. So I just use Talk.
I believe, John, there you're talking about the Wi-Fi access point, I guess, rather than the broadband router. My Virgin router, it connects to the,
well, Virgin is different, of course, right? I'm just using, BT's standard rubbish telephone line. Yeah. Eventually we're going to have in Wolverhampton, eventually fibre everywhere, but maybe, I don't know when that'll happen. At the moment, they're digging up all the pavements everywhere themselves. But anyway, so I just buy a standard TP-Link router, and there you can do really whatever you want, and fairly simply. And I used to use Netgear routers because I found they were the best ones. I was told, and they used to work fine. But TP-Link ones seem fine to me as well. Obviously, as you said, if you're using Virgin Media, you're not using a standard, if you like, BT Open, whatever they call themselves now, BT Open something or other. You're using a slightly different thing. Again, I'm such a meanie, I would never dream of buying a Mac because I just regard their pricing as unbelievable. So I'm running a Minis something 260 with a Ryzen, and it takes at it, including 3D modeling. And and I look at Mac prices and I think they're unbelievable. Yeah, but that's me. I'm me.
Thank you. Sorry, Paul. Because of the echo.
Yeah. Sorry about that. I lost the connection. You're absolutely right. Really, the best way to operate is to run and use and buy your own router and configure it the way you want, because the ISPs lock theirs down to a large extent, and they're also responsible or irresponsible for the updates too, in terms of patching. They don't always do it, and they can get really far behind. However, to do that, you have to still use what the ISP provide you with almost by contract, but you can turn that into a modem. And if you put it in modem mode, you then connect your router to that, and you can do what you want with your own router after that. But you still have to use their device to connect to their network for various legal reasons and things like that.
Yep, good point.
I will have to give an advert here. I use Zen, and they supply Fritzbox routers, which are, I think, probably as good as anything you're likely to get. They're German. They don't mess about with anything. They don't shape your data or anything. And the Fritzbox is extremely reliable and very fast. I have to say that, yes, Zen is not the cheapest, but then you get what you pay for. And if you want to get any technical advice, you ring somebody up and you speak to somebody in this country who knows the technical information, can answer it and will answer it. And if they need to call you back, they will. And I think it's worth paying for.
Yeah, good point. I mean, I've got my road dig up with City Fibre, so Zen is top of my list as well once they connect me. Okay. Any other points then around, ad blocking, DHCP, DNS, that sort of stuff? Oh, go on, Tom.
Not a comment on that, but I have to say, not entirely facetiously, this is encouraging me to get involved, and I can see an enormous amount of time being consumed on my part trying to get this all done. But it's very illuminating. You've lifted a cloud on a whole variety of things. Thank you so much.
Okay, good. Glad it's useful. It feels like we're coming to an end. The last thing I want to say is, if you've got any ideas for future talks, if you know something about a subject you want to share about it, do a presentation, or any topics you'd like to see us covered, then do drop us an email, computing@u3acommunities.org, and I'm sure we can schedule it in the future meeting. Anything from anyone else before we hang up? Okay, so thank you very much for attending. Hope that's been useful. And I shall...
I have one thing. Thank you very much, Peter, for all of the hard work you put into the new website. I think that work will pay off. I'm just very grateful.
Thank you. All right, look out for this hopefully automated email for next month's meeting. And I'll apologise now in case that gets screwed up, but hopefully that works right first time. Neil's laughing.
Thanks a lot.
All right.
Bye-bye.
Thanks, Peter.
Great.
Great.
Okay.
Great.
Thank you very much.
Yeah, very good.